Hello dear students, after a long time we are going to study chemistry. Okay, right now you are learning about electrochemistry, right? Today I am going to teach you about electrolysis. Okay, in electrochemistry, chemical energy converts into electrical energy, but in electrolysis, electrical energy will convert into chemical energy. Okay, both are opposite. In electrochemistry, chemical energy converts into electrical energy, but in electrolysis, electrical energy converts into chemical energy. Fine. In a vessel, you are taking a solution of specific salt or compound, which is called electrolytic solution. As an example, here we are taking acidic H2. What? Acidic H2. It means acidified H2. यहाँ पे acid H2 ही है, लेकिन उसमें थोड़ी सी amount, in a few amount H2SO4 is added. Now you have to put two electrodes. Which one is connected with positive? It called anode. Which one is connected with negative? It called cathode. Okay. Positive anode, negative cathode. In electrochemistry, anode is negative and cathode is positive. But in electrolysis, anode is positive and cathode is negative. Because of redox reaction on different electrode, we get product. We get what? Product. So in a simple sense, if in an electrolysis solution, in electrolytic solution, if we put two different electrode and apply specific amount of electrical energy, because of redox reaction, we get product on different electrode on anode and cathode. The whole process is called electrolysis process. Okay, like here H2O will give half O2 plus 2H plus 2 electron. It's an oxidation reaction which is occur on anode. On the same side, on cathode, 2H2O plus 2 electron will give H2 plus 2OH minus. It's a reduction reaction which occurs on cathode. On a final stage, H2O converts into H2 gas and half O2 gas. Because of electrolysis, H2O gives H2 on cathode and O2 on anode. The whole process called electrolysis process, and electrolysis is a redox reaction, but here we are using electrical energy to gain chemical product. So here electrical energy converts into chemical energy. Fine. As an example, if we are taking NaCl molten, it means liquid, we will get Na solid plus half Cl2 gas. Based on, Na on cathode, chlorine on anode. Clear? Easy. there are few points which describes electrolysis. Here, first one is electric energy converts into chemical energy. It's an redox reaction. Different products on different electrodes. Here, oxidation on anode and reduction on cathode. Another thing, anode is positive and cathode is negative. We are using to gain metal to make electroplating, to gain solution like KOH, NaOH, etc. So these are the basic points of electrolysis. Fine. In electrolysis, you have to understand the law of Faraday. Law of Faraday. We will study about that law of Faraday after a few time. But first of all, we are clearing some simple points like Na plus liquid. It will gain an electron and converts into Na solid. So if 1 mole electron gives 1 mole sodium. 1 mole electron मतलब 6.022 into 10 raised to 23 electron gives 1 mole sodium. Now 1 electron is equal to 1.6 into 10 raised to minus 19 coulomb. Then 6.022 into 10 raised to 23 electron is equal to how many coulomb? So 1 mole electron is equal to approximately 96,500 coulomb, which is called 1 farad. Which called what? 1 farad. So according to this, 1 Faraday gives 1 mole sodium. So if I apply 2 Faraday, it will give 2 mole sodium. Same, if you are talking about magnesium plus 2, it requires 2 electron, gives Mg. So if we apply 2 Faraday electron या फिर 2 Faraday electrical charge, it will give 1 mole magnesium. Same, on the basis of aluminium plus 3 electron gives aluminium. It means 3 Faraday electrical charge will give 1 mole aluminium. Okay, so Faraday's first rule is W proportional to Q. W proportional to what? Q. It means because of electrolysis, whatever product we gain, it is directly proportional to electrical charge. So if we apply 1 Faraday to 1 mole Na plus, it will give only 1 mole sodium. But if I apply 2 Faraday, it will give 2 mole sodium. So the product or amount of product is directly proportional to charge. It's directly proportional to what? Charge. As an example, 2 Faraday will give 1 mole magnesium. 1 Faraday will give what? Half mole magnesium. The amount of charge decreases, product decreases. 3 Farad gives 1 mole aluminium, 1 Farad gives 1 by 3 mole aluminium. Clear? Okay. So Faraday's first rule is, if we apply specific amount of charge, it will give specific amount of product. It means with the help of electrolysis, the amount of product we gain is directly proportional to amount of charge we applied. Okay. Now, the another thing is equivalent weight. I am going to teach you the different law of Faraday, but not directly. First, we study about what is Faraday and how we gain product, and after that we study about Faraday's first rule. Now, equivalent weight is equal to atomic mass, if there is molecular mass, atomic mass upon number of electron or Faraday we pass, or atomic mass upon change in oxidation number. As an example, Na++ electron gives Na, then equivalent weight is equal to m upon 1. सोडियम का एटॉमिक मास क्या है 23 by 1, इट्स इक्विवेलेंट वेट. बट इफ वी अप्लाई Mg2 plus 2 electron gives Mg, then equivalent weight should be 2 electron m by 2, यानी कि 24 by 2 is equal to 12. 12 is the equivalent weight of what? Magnesium. As an example, aluminium plus 3 electron. Aluminium equivalent weight should be m by 3. Atomic mass of aluminium is 27. 27 by 3 is 9. Okay. So, equivalent weight of any compound or any ion is atomic mass or molecular mass of that compound or ion divided by number of electron or number of Faraday or change in oxidation number. With the help of this equation, we can find atomic mass equivalent mass of any ion, any atom, any compounds or ion. Okay, fine. With the help of this, if we combine or join 3 different electrolytic solutions like Na+, Mg2+, and aluminum 3+, in a specific series and apply or pass same amount of charge, as an example 1 Farad. You can take 2 Farad, 3 Farad, whatever. If we join 2 or more than 2 different electrolytic solution in a series and passes same amount of charge, then the product is directly proportional to equivalent weight of that ion. What? Equivalent weight of that ion. It is second rule of Farad. It is what? Second rule of Farad. See, Na++ electron gives Na. 1 Farad is equal to 1 Na. Clear? 1 Na. Equivalent weight. Now, Mg2 plus 2 electron gives Mg. 2 Farad is equal to 1 Mg. Then 1 Farad should be 1 by 2 Mg. Last, aluminium plus 3 electron gives aluminium. 3 Farad is equal to 1 mole aluminium, then 1 Farad is equal to 1 by 3 aluminium, 1 by 2 magnesium, 1 by 3 aluminium, they are equivalent weight of the different atom or different ion. Same charge, 1 Faraday, 1 Faraday, 1 Faraday. Na is to Mg is to Al. Product is directly proportional to what? Equivalent weight. Sodium 1, but magnesium is 1/2 and aluminum is 1/3, which is equivalent weight. LCM should be 6. 6 is to 3 is to 3. 2 is our answer. Clear? Okay. So, first rule is the amount of product is directly proportional to charge, whatever we apply. And the second one is, if we combine more than two or more than two different electrolytic solution in a series and apply same charge, then the product or amount of product is proportional to what? Equivalent mass of that element. Fine? Now, we know that electrical current is equal to Q by T. It means charge upon time. So Q is equal to I multiplied by T, where is unit of Q is C coulomb, A ampere second. Okay. So another thing, 1 minute is equal to 60 seconds and 1 hour is equal to 3600 seconds. Now, different questions. Q is equal to 3 Faraday. Mass of Mg is equal to what? First of all, write down an equation. Mg2 plus 2 electron gives Mg. It means 2 Faraday will give 1 mole Mg. 1 mole Mg is equal to, it means 2 Faraday will give 24 gram magnesium. What we have? 3 Faraday. The mass of magnesium is equal to 3 multiplied by 24 upon 2, 36 gram. Okay, next question. If (10 ampere electric current is passed for 965 seconds, mass of aluminum we give. Okay, now aluminum plus 3 electron gives aluminum. 3 Faraday will gives 1 mole aluminum. It means 3 multiplied by 96500 coulomb is equal to 27 gram aluminum. Q is equal to what? I multiplied by T. 10 multiplied by 9650 coulomb. Okay, if 3 into 96500 coulomb will give 27 gram aluminum, then 9650 coulomb is equal to what? Then 9650 multiplied by 27 upon 3 multiplied by 96500, 9, 10, 9 by 10, 0.9 gram aluminum is your answer. Is it clear? So, whenever you want to calculate the mass of product, you have to understand the reaction and the Faraday, whatever we pass. Okay, we can calculate this question differently also. Like 3 Faraday. 2 Faraday is equal to 1 mole. 3 Faraday is equal to how much? Then 3 by 2 mole. Now, mole is equal to mass upon atomic mass. Then mass equal to atomic mass multiplied by mole. Atomic mass 27, mole is equal to 3 by 2. Answer will be 36. Same here. Q is equal to 965, 0 coulomb. Faraday is equal to Q by 965 00 coulomb. 9650 upon 965 00 is equal to 0.1 farad. Okay, see. Point 1 farad. 3 Faraday is equal to 1 mole. 0.1 Faraday is equal to what? 0.1 by 3 mole. Same. Mass equal to mole multiplied by atomic mass. Mole equal to 0.1 by 3, atomic mass 27, 9 by 0.1, 0.9 gram is your answer. Clear? So simple thing is, you have to understand the concept, the whole concept of electrolysis. After that, you can calculate your question differently. If you want directly, like 2 Faraday is equal to 1 mole, 2 Faraday is equal to 24 gram, then 3 Faraday is equal to how many gram? Like 2 Faraday is equal to 1 mole, 3 Faraday is equal to how many? 3 by 2 mole. Then mass equal to what? The answer, the method is based on you. Whatever method is convenient to you, you can calculate like this, like that. Okay, fine. Another thing. We will study about different questions. Okay, but after this point, product after or because of electrolysis is based on 3 points. First one is amount of charge or electric current. Okay, if amount of charge increases, the amount of product is increasing, as we study in Faraday's first rule. Second one is type of electrode, and third one is concentration of electrolytic solution. Okay, the first parameter is studied by us. Okay, now type of electrode. Electrolysis of aqueous solution of CuSO4 by copper electrode. aqueous solution of what? CuSO4. As an anode, we are using impure copper. As a cathode, we are using pure copper. As impurity, there are silver, platinum and aurum, which are not oxidized or not taking part in electrolysis. So, on anode, there is a copper, and in between that copper as an impurity, silver, platinum and aurum is present, but they are not oxidized or they are not taking part in electrolysis. So only copper get oxidized. So copper will convert into copper 2 plus 2 electron. Copper solid will convert into copper 2 plus aqueous into 2 electron. It's an oxidation reaction, but in between this copper as an impurity, silver, platinum and aurum, it not get oxidized, and extracted at anode, which is known as a anodic mode. Which is known as what? Anodic mode. On the same side, it's the aqueous solution of CuSO4. With the help of electrolysis, concentration of copper 2 plus increases. That copper 2 plus transfers to cathode and get reduced. So on cathode, copper 2 plus aqueous will accept 2 electron and converts into copper solid. It's a reduction reaction. Copper 2 plus 2 electron gives copper. Like copper 2 plus 2 electron. Copper solid gives copper solid. So here, after the whole process, after using whole electrical energy, we gain copper from copper. What is the use of this? Here, from anode, from impure copper, we get pure copper. So, with the help of electrolysis of aqueous solution of CuSO4 with copper electrode, we gain pure copper from impure copper. So, we can use this process for the purification of copper or purification of metal, but as an anode, we have to use impure metal, and as cathode, we have to use pure metal. Fine. But like electrolysis of aqueous solution of CuSO4 with the help of inert electrode or platinum electrode, same. Aqueous solution of CuSO4, anode positive platinum, cathode negative. We can use platinum or any spoon, any metal, whatever you want. Okay. Because of the difference in EMF series, in a value of EMF, in this process copper 2 plus get reduced, but SO4 minus 2 does not oxidize. Okay, does not oxidize. Oxidation of H2O is possible. See, in a electrolysis of aqueous solution of CuSO4 with the help of inert electrode, we are using platinum as an anode. We can use platinum as cathode also, but we are using spoon, a metal spoon, as a cathode. In an aqueous solution of CuSO4, copper 2 plus get reduced, but SO4 minus 2 cannot oxidize, but oxidation of H2 is possible. But anode, H2O get oxidized, H2O will give half H2 gas, half O2 gas plus 2H plus aqueous plus 2 electron on a cathode. Copper 2 plus 2 electron converts into copper, aqueous, solid. So here we gain copper. So if we are using a different metal, then there is a layer of copper on the surface of that metal. So we are using this method or using this electrolytic method for the electroplating of metal. Electroplating of what? Metal. If we are using metal spoon as a cathode, we get plating of copper. Plating of what? Copper on that spoon. Another thing here as a product, anode gives oxygen gas, cathode gives copper metal, but in a solution H plus and SO4 minus 2 cannot oxidize, so SO4 minus 2 is also present. 2H plus and SO4 minus 2 gives H2SO4, so solution is slightly acidic after electrolysis. Clear? So if we are electrolysis aqueous solution of copper sulfate with the help of copper electrode, then we will get pure copper. But if we are electrolyze aqueous solution of copper sulfate with the help of inert electrode, on cathode we gain oxygen, on anode we gain oxygen, on cathode we gain copper. In a solution we gain H2SO4, so after the electrolysis solution will be slightly acidic. So product after electrolysis is based on type of electrode also. Repeat, if we are using copper as an electrode, product should be copper sulfate. Okay. If we are using inert electrode as a electrode, then product should be oxygen on anode, copper on cathode, and H2SO4 in a solution. Fine? Okay. The third factor, like concentration of electrolytic solution. First one is electrolysis of NaCl, molten, as an anode. We are using steel. As a cathode, we are using graphite. NaCl, liquid, will give Na plus liquid, Cl minus liquid. On anode, 2Cl minus liquid will give Cl2 gas plus 2 electron. On cathode, 2Na plus liquid plus 2 electron gives Na solid, 2Na solid. So after the complete electrolysis, as a product, anode will give fluorine gas, cathode will give sodium metal. But if you are doing electrolysis of concentrated aqueous solution of NaCl with the help of graphite or platinum electrode, with the help of what? Graphite or platinum electrode, NaCl solid, H2O will give Na plus aqueous, Cl minus aqueous, concentrated aqueous solution, molten NaCl or fused NaCl, concentrated aqueous solution of NaCl, reduction of Na plus, not possible, reduction of H2O is possible. Same. Oxidation of Cl minus is possible. If oxidation of Cl minus is possible, at anode 2Cl minus gives Cl2 gas plus 2 electron, but on cathode reduction of H2O is possible. 2H2O plus 2 electron will give H2 gas plus 2OH minus aqueous. Okay. After the complete reaction, as anode we get chlorine gas, at cathode we get H2 gas in a solution. OH minus is present as aqueous. Na plus does not reduce, so Na plus aqueous is also present. Na plus aqueous, OH minus aqueous will give NaOH, and with the help of NaOH, solution becomes basic after electrolysis. So you can see that the product of electrolysis or after electrolysis is based on concentration of that electrolytic solution. Like we are here electrolytic NaCl, but here molten NaCl or liquid NaCl is present. Here concentrated NaCl is present. In a electrolysis of NaCl liquid, product should be chlorine gas and sodium metal. But in a electrolysis of concentrated aqueous solution, at anode chlorine, cathode H2, in a solution NaOH. So if we change concentration of electrolytic solution, the product will change. Okay. If we electrolyze electrolysis of dilute aqueous solution of NaCl with the help of graphite or platinum electrode. graphite or platinum electrode, NaCl solid, Na plus aqueous, Cl minus aqueous. Okay, it's a dilute solution. Reduction of Na plus not possible. Reason behind that is value of EMF. Oxidation of Cl minus is not possible, but oxidation and reduction of H2O is possible. So, if you are using dilute solution of NaCl, electrolysis will occurs of H2O, not Na plus and Cl minus. So at anode, H2O gives half O2 gas plus 2H plus 2 electron. At cathode, 2H2O plus 2 electron gives H2 gas plus 2OH minus aqueous. In a solution or in a cell, 2H2O will give 2H plus aqueous and 2OH minus aqueous, which is present in solution, and net reaction is H2O liquid will give H2 gas and half O2 gas. H2 gas on cathode, O2 gas on what? Anode. So it is clear that if we change concentration of electrolytic solution, the product will change. Molten NaCl, chlorine on anode, sodium on cathode. Concentrated NaCl aqueous, chlorine at anode, hydrogen at cathode, NaOH in solution. But if you are using dilute solution of NaCl, H2 on cathode and oxygen on anode. So concentration of the electrolytic solution affect product of electrolysis. Electrode which are used in electrolysis process is affect product of electrolysis or after electrolysis, and charge whatever we applied on in electrolysis process is also affect the amount of product. Okay, in this lecture we understand what is electrolysis and different kind of electrolytes, Faraday's laws. Okay, learn that whole topic, and if you have any query or any doubt, you can ask me. Okay dear students, thank you so much.